This one is obviously on simplifications, as you might have noticed. So knowing your powers, squares, cubes, something that we constantly hammer in classes, must know. It's not just a part of indices or algebra per se, but that can be heavily tested, or rather is tested in concepts on or questions on simplification, as you can see here, right? So let's check 0.0625 and the fourth root of that. So it is 625 upon 10,000. 625 is the fourth power of 5. 10,000 is the fourth power of 10. Effectively can be written as 0.5 raised to 4 and the fourth power, fourth root. So therefore 0.5. But do you really need to do all this in the context of solving it in the exam? No, you should not have, right? Similarly, 0.00 or 208, 008 cube root would be 0.2 cube, right? It is 8 upon 1000. 8 is 2 cube, 1000 is 10 cube. Therefore, it is effectively 0.2. What about 0.09 and the square root? It is 9 by 100. So therefore, 3 square by 10 square. So 0.3 square and therefore 0.3. Now let's look at the denominator. An interesting part here is the fifth. Okay, so the fifth root of 32. What is the fifth root of 32? It is 2. So it is 2 raised to 5 whole fifth root. So therefore, it is 2. Now, what you need to observe here is, because one might be in a hurry, and if you look at the denominator, that extends beyond 62.5 all the way up to 32. The cube root is not just limited to 62.5. All right. So if you note this carefully, you will realize that it is not just limited to 62.5, but it is extending beyond that for the entire set of values in the denominator. So therefore, it would be 62.5 into 2, which is 125. And the cube root of 125 is 5. Otherwise, if you get stuck up at that point, you might tend to think, about the cube root of 62.5. That's where one might take some more time if you don't observe them. Okay, so now you have got all the values. All you have to do is to just plug the values in the numerator and the denominator and arrive at the answer. So 0.5, 0.2, 0.3, 1 minus 1 by 5, the answer is 0. Okay. Yes, thank you.